I'm Anil Kumar, and in this video we will understand different operations which can be performed on functions. Let the function f be defined as set of these points, right? And g as set of these points, right? So we are given the coordinate points for the functions. Now we need to find what is sum of these functions, f plus g, what is the product of these functions, and what is f minus g inverse. That is what we need to figure out. Remember one thing, that all these function operations can be performed for common domain, right? So if the domain is same, then you can add, subtract, and multiply the functions. So keeping that in mind, let us start with the very first one, which is f plus g. Now the values are, at minus 2 it is 1 for f, and for minus 2 for g it is 2. So we can simply add them up. So at x value of minus 2, when you add the values of f and g, you get 1 plus 2 as 3. So that is a coordinate point on f plus g. So let me write this as a set. Now 0. On g we have 0, 0. On f we have 0, 1. So adding corresponding values of y for x values of 0, we get 0 plus 1 as 1. So 0 is the common domain point for both f and g, and the y values will be 1 plus 0, which is 1. Now next is 1, and for 1 in g, we have 1 in f also, so we can add them up. So for x value of 1, when we add the value of functions f and g, we get 5 plus 2 as 7. Next point is 3. At x equals to 3, f is also defined. It is 4 at 3, g is 3 at 3, so 3 plus 4 is 7. So at 3, we get f plus g as 7. Okay, 7. For 4, well, there is no point corresponding to x equals to 4 or even 5, so that is it. So we can only add these 4 points, and that's what we get. So these are common in f and g, and so we can add these 4 points. When you have to find the product, we have to do exactly the same thing. So we discovered that there are 4 points, 4x values, for which we also have y values, right? And so they can be performed with the operation of addition, subtraction, multiplication, or division for that matter. So fg, so always you have to write the x point as such. So at minus 2, when you multiply the corresponding y points, you get 2 times 1 as 2, so the point is 2. For 0, the product is 0 times 1, which is 0. At 1, product is y times 5 times 2 as 10. And at 3, you have to multiply 3 by 4, as the y values are 3 and 4 respectively for g and f, right? So you get 12. So that is fg. Now we have to do f take away g inverse. So it's a good idea to first write what is g inverse, right? So let us write g inverse. So let me add g inverse here. So g inverse is equal to, we have to swap x and y values. So we get 2 minus 2, 0, 0, 5, 1, 3, 3, minus 2, 4, and minus 1, 5. And now we have to take away g inverse from f. So let's start comparing. So let's start with the very first position, which is x equals to minus 2. Do we have minus 2 in g inverse? Yes, we do, right? So that point corresponds. They have the same x value. So we can perform the operation of difference between f and g inverse. So we get at minus 2, 1 minus 4 is minus 3. So that's the point. Now at minus 1, do we have minus 1 here? Yes, we do. 5. So at minus 1, the value should be 0 minus 5. So at minus 1, we get minus 5. 0 minus 5. 0. Do we have 0? Yes, 0, 0 is a point on G inverse. So 0, 1 minus 0, 0 gives us 0, 1, right? So at 0, 1 minus 0 is 1. 1, 2. So do we have 1 here? No. So we cannot take away that point since we do not have a common domain. Now let's look for 2, 3. X value of 2 I am looking for. The very first point is 2 minus 2. So 3 minus minus 2 gives me 5. So we get 2, 5 as the coordinate point. 3 and 4. Let's look for 3. Yes, we have 3 and 3. So 4 minus 3 is 1. So we get the point 3 and 1. So that is F minus G inverse. I hope with this you appreciate how we can perform operations on functions. So important thing which we have learned is we can only do addition, subtraction, multiplication or similar operations, but what is important here? Common domain. Right? So operations can be performed provided the domain is common. At that point we can perform this operation. So that is what we learned from this video. Thank you.